The National Electrical Code, or NEC, doesn't single out three-phase portable pressure washers with dedicated sections. The electrical safety focuses for such equipment fall under the broader articles addressing portable appliances and electrical equipment. Let's break down the key aspects to consider for a 460 volts 20 amps three-phase portable pressure washer with a 4-wire cord and plug, focusing on grounding, circuit protection, cord and plug requirements, and the availability of three-phase ground fault circuit interrupter, or GFCI, devices. Firstly, grounding is paramount. The pressure washer must have a reliable ground connection. This is achieved through a properly installed grounding conductor, typically the green wire in the 4-wire cord, connected to the equipment grounding terminal within the pressure washer. This grounding conductor must then be connected to the building's grounding system, ensuring a low impedance path for fault current to return to the source. This path facilitates the quick operation of overcurrent protective devices like circuit breakers or fuses, minimizing the risk of electrical shock. Secondly, circuit protection is a must for any electrical equipment. The three-phase pressure washer needs to be protected against overcurrent, which could arise from short circuits or excessive loads. This protection is provided by a circuit breaker or fuses in the electrical panel feeding the pressure washer's receptacle. The overcurrent device must be sized appropriately, meaning its ampacity rating should be matched to the maximum current draw specified by the pressure washer's manufacturer, typically found on the equipment's nameplate. It's important to consult NEC Article 430 for motor circuit protection requirements, as pressure washers often use motors. Thirdly, the cord and plug assembly must be appropriately rated for the voltage and current demands of the pressure washer. In this instance, a 460 volts 20 amps rated cord and plug is specified. The cord must be of sufficient gauge to handle the 20 amps current continuously without overheating. The plug must be a 4-wire type, consistent with the pressure washer's wiring configuration, which includes 3-phase conductors and a grounding conductor, but no neutral. Using the correct NEC configuration plug ensures proper connection and prevents accidental misconnection to other voltage systems. Keep in mind NEC Article 400 addresses requirements for flexible cords. Moving on to the topic of three-phase GFCI devices, it's worth noting that these are not as common as their single-phase counterparts. The reasons are twofold. Firstly, the design and manufacturing of three-phase GFCIs are more complex, adding to their cost. Secondly, the demand for three-phase GFCIs in portable equipment applications is relatively lower compared to single-phase applications. Although availability may be limited, it is crucial to understand the purpose and importance of a GFCI. A GFCI is designed to detect even small imbalances in current between the phase conductors and the neutral, or ground, in a circuit. These imbalances can indicate a ground fault, where current is leaking to ground, potentially through a person. A GFCI will quickly trip the circuit, cutting off power and preventing electrical shock. Now, let's talk about recommendations. While the NEC doesn't explicitly spell out requirements for three-phase portable pressure washers, some general guidelines based on the code and best practices will help. Firstly, always ensure proper grounding. Verify the grounding conductor is securely connected at the pressure washer and at the electrical panel. Check the continuity of the grounding path using a multimeter to confirm low resistance. Secondly, select the correct overcurrent protection. Determine the maximum current draw from the pressure washer's nameplate. Consult NEC Article 430 for motor circuit protection guidelines. Choose a circuit breaker or fuse with an ampacity rating that protects the equipment without causing nuisance tripping. Thirdly, use the appropriate cord and plug. Inspect the cord for any damage before each use. Ensure the plug is securely connected to the receptacle. Never use extension cords unless absolutely necessary, and if used, ensure they are of the proper gauge and rating for the pressure washer. Fourthly, consult the manufacturer. Always refer to the manufacturer's installation and safety instructions for the pressure washer. They may provide specific recommendations or precautions related to the three-phase power system. Fifthly, consider a three-phase GFCI. Although they may be less common and more expensive, Incorporating a three-phase GFCI into the circuit feeding the pressure washer adds an extra layer of safety, especially in damp or wet environments. Sixthly, regular inspections. Conduct regular inspections of the pressure washer, cord, plug, and electrical connections. Look for any signs of damage, wear, or corrosion. Address any issues promptly to prevent potential hazards. And seventhly, qualified personnel. All electrical work related to the three-phase pressure washer should be performed by qualified and licensed electricians who are familiar with three-phase power systems and the NEC requirements. To elaborate on the four-wire configuration, the absence of a neutral conductor in the four-wire system means that the load is exclusively a three-phase load balanced across the three phases. This configuration is common for motors and other equipment that doesn't require a neutral connection. The four wires are typically three-phase conductors, often labeled as A, B, and C, or lone L2 and L3, and a grounding conductor, usually green. The voltage between any two-phase conductors in a 460 volts three-phase system is 460 volts. The absence of a neutral wire simplifies the wiring and reduces the number of conductors required. However, it also means that the system cannot easily provide single-phase power for other devices. A few more points that will help in understanding the three-phase portable pressure washer scenario are: firstly, understanding the voltage. The 460 volts refers to the line-to-line voltage in the three-phase system. This is the voltage measured between any two of the three-phase conductors. The voltage to ground from each phase will depend on the specific grounding configuration of the system, such as Y or delta. Secondly, the 20 amps rating indicates the maximum current a pressure washer is designed to draw under normal operating conditions. This rating is used to size the circuit breaker, fuse, and conductors feeding the equipment. It's important not to exceed this current rating to prevent overloading the circuit. Thirdly, NEC Article 430 covers motors, motor circuits, and motor controllers. Since pressure washers typically use motors to drive the pump, it's important to consult this article for specific requirements related to motor protection, control, and wiring. This article provides guidance on selecting the appropriate overcurrent protection, conductor size, and disconnecting means for the motor circuit. Fourthly, NEC Article 250 addresses grounding and bonding requirements. This article outlines the requirements for grounding electrical systems and equipment to ensure electrical safety. It covers topics such as equipment grounding conductors, grounding electrodes, and bonding of metallic parts. Following these requirements is crucial for preventing electrical shock and ensuring proper operation of overcurrent protective devices. Fifthly, NEC Article 400 covers flexible cords and cables. This article provides requirements for the construction, opacity, and use of flexible cords and cables. It specifies the types of cords that are permitted for different applications, as well as the conditions under which they can be used. When using a cord and plug connection for the pressure washer, it's important to select a cord that meets the requirements of this article. Sixthly, GFCI protection is addressed in NEC Article 210.8 and other relevant sections. While the code may not explicitly require GFCI protection for three-phase portable pressure washers, it's a good practice to consider GFCI protection, especially in damp or wet locations. GFCI devices can help prevent electrical shock by detecting ground faults and quickly interrupting the circuit. Lastly, local codes and regulations can influence your installation. In addition to the NEC, local codes and regulations may have additional requirements for electrical installations. It's important to check with the local electrical inspector or authority having jurisdiction, or OJ, to ensure compliance with all applicable codes and regulations. Let us explore some additional considerations. Firstly, the disconnecting means. The NEC requires a disconnecting means to be provided within sight of the pressure washer or to be capable of being locked in the open position. This disconnecting means allows for safe disconnection of power to the equipment for maintenance or repair. It can be a circuit breaker, a switch, or a plug and receptacle. Secondly, the motor overload protection. In addition to the circuit breaker or fuse protecting the entire circuit, the motor itself should have overload protection. This protection can be provided by thermal overloads built into the motor or by a separate overload relay. The overload protection is designed to protect the motor from overheating due to excessive current draw. Thirdly, the wiring methods. The wiring from the electrical panel to the receptacle for the pressure washer must comply with the NEC requirements for wiring methods. Depending on the location and type of installation, the wiring can be installed in conduit, cable tray, or other approved wiring methods. The conductors must be sized appropriately for the load and protected from physical damage. Fourthly, the receptacle. The receptacle for the pressure washer must be of the correct NEMA configuration for the voltage and current rating of the equipment. It must also be properly grounded and installed in accordance with the NEC requirements. The receptacle should be protected from the weather if located outdoors. Fifthly, maintenance. Regular maintenance of the pressure washer and its electrical components is important for ensuring safe and reliable operation. This maintenance includes inspecting the cord, plug, and wiring for any signs of damage, cleaning the motor and pump, and lubricating moving parts. Sixthly, the training. Anyone who operates or maintains the three-phase portable pressure washer should be properly trained on its safe use and operation. This training should include instruction on the electrical hazards associated with the equipment and the proper procedures for disconnecting power and performing maintenance. Lastly, the documentation. Keep a copy of the pressure washer's instruction manual and any relevant electrical diagrams or specifications. This documentation can be helpful for troubleshooting problems and ensuring that the equipment is properly installed and maintained. A well-maintained and documented system is a safe system. Considering the implications of using a three-phase system compared to a single-phase system is crucial for understanding the design and safety concerns. Firstly, power delivery. Three-phase power provides a more constant and efficient power delivery compared to single-phase power. In a single-phase system, the power fluctuates with each cycle of the alternating current, whereas in a three-phase system, the power is more evenly distributed across the three phases, resulting in smoother operation of motors and other equipment. Secondly, conductor efficiency. For the same amount of power, a three-phase system requires smaller conductors compared to a single-phase system. This is because the current is distributed across the three phases, reducing the current in each conductor. This can result in cost savings and easier installation. Thirdly, motor efficiency. Three-phase motors are generally more efficient and have higher starting torque compared to single-phase motors. This makes them well suited for applications requiring heavy loads or frequent starting and stopping. Fourthly, voltage drop. Three-phase systems tend to have less voltage drop compared to single-phase systems for the same load and distance. This is because the current is distributed across the three phases, reducing the voltage drop in each conductor. Fifthly, complexity. Three-phase systems are generally more complex than single-phase systems, requiring more sophisticated wiring and control equipment. This can make them more challenging to install and maintain. Sixthly, safety. Three-phase systems have the potential for higher fault currents compared to single-phase systems. This means that proper overcurrent protection and grounding are even more important in three-phase systems to prevent electrical shock and equipment damage. And lastly, applications. Three-phase power is commonly used in commercial and industrial applications where large amounts of power are required, such as factories, hospitals, and office buildings. Single-phase power is more common in residential applications where the power demands are lower. Some final details to keep in mind when dealing with three-phase systems and equipment are firstly, phase rotation. In a three-phase system, the phase conductors must be connected in the correct sequence, known as phase rotation. If the phase rotation is incorrect, the motor may not start or may run in the wrong direction. It's important to check the phase rotation when installing or troubleshooting three-phase equipment. Secondly, voltage imbalance. Voltage imbalance occurs when the voltages on the three phases of a three-phase system are not equal. Voltage imbalance can cause motors to overheat and fail. It's important to measure the voltages on each phase and correct any imbalance. Thirdly, harmonic distortion. Harmonic distortion is the presence of unwanted harmonic frequencies in the electrical system. Harmonic distortion can cause equipment to overheat, malfunction, and fail. It's important to measure the harmonic distortion and take steps to reduce it. Fourthly, power factor correction. Power factor is a measure of how efficiently electrical power is being used. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction can be used to improve the power factor and reduce energy costs. Fifthly, surge protection. Surge protection devices, or SPDs, can protect electrical equipment from damage caused by voltage surges, such as those caused by lightning or switching transients. SPD should be installed on the incoming power lines to protect sensitive equipment. Sixthly, arc flash hazard. Arc flash is a dangerous electrical phenomenon that can occur when there is a fault in an electrical system. Arc flash can cause severe burns, injuries, and even death. It's important to be aware of the arc flash hazard and take steps to protect workers from it. And lastly, lockout-tagout or LOTO procedures. Lockout-tagout procedures are used to ensure that electrical equipment is de-energized and locked out before maintenance or repair work is performed. LOTO procedures are essential for preventing electrical accidents.